So welcome to the third machine learning section. So I'm the session chair. I'm Kaiwei Chang at UCLA. And let's welcome our first talk. So Eric will talking about the universal adversarial trigger for tagging and analyzing NLP.
Great, thank you. Yeah, so today I'm going to present a new work on sort of a new class of adversarial attacks that'll make you rethink how our models are working under the hood. This is work I did at the Allen Institute for Artificial Intelligence, and I'm now a PhD student at UC Berkeley. So I want to start by thinking just broadly about sort of where NLP can go wrong. So NLP systems are sort of a combination of data and a model. So first, we could have issues in our data sets. We can have things like annotator biases, we can have things like imbalanced classes or noise in the labels, and we can also have problems in our model, right? The model can be overconfident, there can be distribution shift that it's not robust to, and overall these lead to sort of weaknesses in our end system. Our systems are not perfect. And these weaknesses can be exploited by adversaries, right? So adversaries looking to do malicious things like craft fake news documents that are just generally hard to detect by machine learning methods. So before talking about sort of how an adversary can do this, we should think about why we should care about it in the first place. So first, there's sort of the sensical sort of security perspective here. So we want to be able to simulate the adversary and sort of model them so we can know how to defend against the adversary. There's also sort of an underrated aspect to adversarial examples, which is thinking of them as almost an analysis or an interpretability method. And the reason for this is that often some of the greatest insights you can get into your model are actually finding when and why it fails. And adversarial examples provide one such way to find these kind of failure cases. So let's talk about some past methods to do adversarial examples in NLP. So let's say we're doing a question answering task where we're given a paragraph and a question. Past work has done stuff such as like inserting typos or inserting paraphrase. So I might change what has to be what how. I might change what has to be what's, or I might do some sort of syntactic reordering of the question, and all of these cause errors for my model. I can also do things like append unrelated information to the paragraph, which causes models to incorrectly pick up on this information. At a high level, all of these things give a method for, given some input, how can I modify that input to cause an error for my model? What universal adversarial triggers let you do is do this in an input agnostic way. So universal adversarial triggers are short phrases that cause a specific model prediction when they're concatenated to any input. Let's break down what this means. So triggers are short phrases, such as zoning tapping fines. You can concatenate them to any input. In this case, we're looking at a bunch of movie reviews that we'd like to do sentiment analysis on. And they cause a specific model prediction. So they're flipping, in this case, from positive to negative model prediction for all of these inputs. So we have a short phrase that elicits a specific response from the model, no matter the input it's applied to. These are highly effective for a wide class of tasks. We can apply them to text classification, which severely degrades accuracy. We can cause question answering systems to predict phrases such as "to kill American people" for many why questions. And we can get language model systems like GPT-2 to generate racist responses, given unracist prompts. And there's a number of implications for these sort of methods before I dive into the results. So because they're universal, they can sort of be widely distributed. So I can create a trigger, I can use it multiple times, and I can also post that trigger out on the internet and let other people use it. They also cause specific errors from our model. It's not just it causes any error, I can elicit a specific malicious response from the model. Triggers are actually widely transferable in our experiments. So that means I don't actually need to know your model architecture or your weights. I can instead attack a similar model that's not the exact same, and the results often transfer. And finally, connecting back to this sort of analysis perspective, triggers are a way to highlight sort of global input-output patterns. So what I mean here is that no matter the input, triggers cause a specific response. So clearly the model has learned some sort of strong correlation with this phrase and the label. And this can help you debug sort of what the model has learned. So let's walk through how we find universal triggers. We start out by just initializing it to a bunch of thes. And we concatenate it to the front of a bunch of examples. In this case, we're looking at positive movie reviews. And we like to flip the model's prediction to be negative instead of positive. The model is doing the right thing and assigning a very low probability to negative in this case. What we do then is we backprop from the negative label, which is what we want the model to change to, which gives us gradient vectors for the 3 the embeddings, basically. We then take those embeddings and dot product them with the word embedding matrix, which gives us a bunch of scalar scores for all the words in our vocabulary. And these scores roughly tell you, if I replace the word the with a different word, how much will it increase the negative probability? We then have a bunch of scores, we take the argmax of those scores, and that becomes the trigger at the next time step, which we just iteratively repeat this process. Eventually we get a trigger that looks like zoning tapping fines. When you concatenate it to a bunch of positive movie reviews, the model predicts negative instead of positive. So let's go through some results and what we can do with triggers. So we'll first look at sentiment analysis. We're going to look at the Stanford Sentiment Tree Bank, and we put the trigger at the front of the movie review. First, looking at a simple model like LSTM with glove embeddings, we have the trigger zoning tapping fines, like we looked at before, and it's able to significantly degrade the model's accuracy on positive movie reviews. You can also look at more complicated models like LSTM with Elmo, and you can repeat a similar process, this time at the character level for Elmo, and it similarly is highly effective at breaking the model. Sticking to text classification, let's also look at natural language inference. So we're going to break down the entailment class. We have 2 models which are highly accurate. They're getting about 90%. And we're able to find a bunch of triggers which degrade the model's accuracy to almost 0. So for instance, adding the word nobody to the hypothesis sentence, the model almost always predicts contradiction instead of entailment. This is an example of sort of these global input-output patterns. It doesn't matter what hypothesis the model sees. The second it sees the word nobody, it thinks the answer is contradiction instead. And these triggers are widely transferable. So we apply it to a different model which has been held out from the generation process, which uses different embeddings, and the triggers are also highly effective at breaking this model as well. Next, we'll look at a more complicated task like question answering. Here we're looking at the squad data set, and triggers are going to be concatenated to the input paragraph. So it's sort of like a fake sentence. And we're going to look at our results grouping questions by WH word, so stuff like who, what, when, where, why. And we're going to try to make the attack targeted. So we're going to pick a specific phrase like, I want the model to say to kill American people as the response when the question is asking why something happened. So for example, you might be given a paragraph about Nikola Tesla and his exercise habits. The model's asked, why did he walk? And it responds with for exercise correctly. Then we append the trigger why, how, because to kill American people, and the model changes its answer to kill American people. We can then swap out a different question in a different paragraph, and the model has the same response. And this happens for about 3/4 of questions and paragraphs. This is another case of sort of, you can see an analysis perspective that it said because, and then the answer immediately follows it. So like, you can see that the model has sort of learned a bias here, where it asks a why question, it sees the word because, and it guesses that the answer is the words immediately following it. You can apply this to a bunch of different questions with different answer types, getting the model to predict things like Donald Trump or random dates. And similarly, you can apply them to held out models, which use different embeddings, different architectures, et cetera. And there's sort of a wide degree of transferability. Finally, we'll look at text generation using GPT-2. So in GPT-2, our goal is to sort of trigger the model to have some sort of specific malicious response. So in this case, we're going to try to get the model to generate racism. We'll do that by having 10 racist sentences, and we'll try to increase the log probability of those sentences using the trigger. We find the prompt, the people man, good dreams blacks. When you condition the model on this nonsensical prompt, it generates racist responses very frequently. I won't cover the exact responses here, but if you take a look at the paper or the slides, trust me, they're very bad. We found that 63% of responses have some sort of explicitly, egregiously racist claim according to human evaluation. And these triggers are also transferable. So we generated them using the smallest GPT-2 model, and we applied them on the bigger models, and they also work on those as well. It looks like OpenAI released the biggest model last night. I tried it this morning, and they also work on that one as well, it seems like. Before I conclude, I want to think more about sort of this analysis perspective a little bit, thinking about sort of why triggers work and why they occur in the first place. And one reason that we look at is sort of dataset annotation artifacts. So for instance, in the SNLI dataset, there's a number of words which are just spuriously correlated with the negative label. So for instance, when you see the word nobody, it's highly often the label is negative for those inputs. And your model might be able to pick up on these biases and sort of solve the task in sort of a fake way without doing the real type of reasoning we want. If we look at the words that are in the triggers, we see there's a high overlap here. In other words, the model has sort of picked up on these artifacts, and triggers are exploiting this weakness. They also sort of confirm that the model is actually using these kind of things. You can see our paper for more details on sort of this analysis perspective. So to conclude, triggers sort of provide a way to generate universal errors for our model. They're sort of broadly applicable to a sort of a wide range of tasks. We look at question answering, text classification, and language generation, though they can be applied to almost any task. They raise security concerns for our systems, as adversaries can use them to break our models in targeted ways, and they provide ways to debug and analyze our models and data sets. Our code and data is available online, and I'm happy to take questions. Thank you.
So I have one question here. So it seems that you need to predefine the number of words in the trigger. So is your result affected by the number of words there?
Yeah, it's sort of just like a parameter, I guess. Using less words is more like stealthy, I guess. Using more words has higher effectiveness. So we have a plot in the paper of just increasing the number of words and then the effectiveness of the adversary, and you see like a sensible increase in the curve. Basically, we just kind of picked the elbow and chose 3 words for the sentiment case, for example.
Hi. Have you thought about a similar sort of attack where the trigger is kind of hidden within the text? So maybe like a paraphrase or something? It seems like this would be far more malicious if you could successfully mount it.
Right. Yeah, so I think interesting extensions are like to make the trigger grammatical or somehow fit not at just the beginning or the end, but somehow be like embezzled in the middle of the paragraph some way. I think you could do this. The grammaticality, you can probably rescore things with the language model, for instance. And I think you can probably get it to work anywhere in the input by sort of averaging over different locations during the generation process.
Okay, any more questions? Okay, so let's send the speaker again.